Next, we're going to talk about something called refractive index. This is a way for us to measure your optical density. Okay, so basically, they are almost 1:1. Basically, the larger the refractive index, the more optically dense you are. Okay, now official definition, very important, is that your speed of light is the ratio of the speed of light in vacuum to the speed of light in the medium. So do take note, one is vacuum, one is medium. Okay, and you are talking about the ratio itself. Right, so just now, if you remember all the way at the very start itself, we talk about the speed of light in vacuum being 3.0 times 10 to the power 8 meters per second, right? So your refractive index is this n over here, whereas the speed of light in the medium refers to your v. Okay, now most schools don't teach Snell's law itself, but basically Snell's law is this formula where basically we have refraction, right? Typically we have refraction here, and that is okay. So we have angle I, we have angle R. So if you were to form this, basically this is medium 1 and this is medium 2. So all we need to do is take the n of medium 1 times sine I is equals to n of medium 2 times sine R. And basically using this, we can actually solve for any angle of incidence, angle of refraction question totally. So once you actually master this skill, literally all of them is no problem already. However, schools don't actually teach this very often. Instead, they'll actually teach you sine I over sine R, which a lot of you will mistaken this for the definition itself. This is not the definition. This is also not your law of refraction. This is just a way for you to calculate refractive index or the angle of incidence or refraction, depending on which one they don't give you. Okay, and there are limitations. Do take note, this one on top must always be the bigger angle. Okay, because if you remember all the way at the very top, first things first, speed of light in vacuum is the fastest. There's nothing faster than speed of light in vacuum. So which means that V will always be a number that is smaller than your C, and therefore N is always greater or equals to 1. Now if you use a smaller angle at the very top, you will actually end up with N being a 0 point something, which doesn't make sense. So therefore, no matter what you do, whether it's R or I, make sure that the numerator is always the bigger angle on top, and don't forget to put sine. Okay, it's not sine. Okay, some students forget to put the sine itself, especially when you just started this chapter, so be very careful. And if you notice, refractive index is speed divided by speed, therefore there is no units for refractive index. Okay, so this one you don't have to memorize itself, but generally the range of the values that is given usually will be within this range itself. Now, if you notice itself, usually when we say refractive index of air is always 1, it's actually 1.00003. So the thing is, usually we assume that it's the same as vacuum, which is just 1 over here. Okay, so if you're traveling from less dense air, basically you can see that this is the bigger angle. Okay, so therefore you can just use sine I over sine R, no problem. However, if you are traveling from optically denser medium to optically less dense medium itself, you'll notice that your I is smaller than your R. So what we'll do is we'll take the bigger R over the smaller I itself. Okay, remember, big angle. Okay, so that's why if you use the sine I sine R formula, which all the schools will teach, just be very careful. You always need to make sure that it's always big angle on top. Therefore, if you actually want to avoid having to, I must always memorize big angle is on top, actually Snell's law allows you to dodge that, because by just writing it in this equation itself, you basically can form those equations without any trouble itself. Okay, so just take note of this. Now, if you notice over here, we can use R over I. Why is that so? How come we can just randomly just swap around your angles all by itself? It's actually based off this principle that I'm going to go through next. Principle of reversibility basically means light will travel in the same path if you were to change the direction of travel. So previously, you can see that light travels in this direction. If you were to do the exact opposite, you will travel back in that same exact position that you see. AKA, if I can see you, you can see me too. So basically, if you are trying to spy on someone with using a mirror itself, if you can see the person, if the person turns and look directly at the mirror itself, he can also see you as well. So don't think that you're being all sneaky. If you can see the person can see you too. Okay? So that's why if you notice R and I, you can actually swap them quite interchangeably itself. So Snell's law. If I use Snell's law over here, I will notice I is in air, right? So I'll write N of air, sine I is N of glass, sine R. So if I have the values, if for example, do I know? So air, the only troublesome part for Snell's law is that we need to memorize that air is 1 and sine I is therefore sine 50, right? And N of glass is what we're trying to solve for, and we have sine of 30 degrees. So you'll notice that when you try to solve for N of glass, you end up with sine 50 over sine 30. Okay, and you will get, press the calculator. Now, if some of you have been doing maths itself, do make sure that your values that you use or the setting that you use is in degree mode, not radian mode itself, and you end up with 1.53 if you use 3 as F. Same thing if you do for the other side itself, you end up with, because we start in glass, we'll write N of glass, sine I equals to N of air, sine R. Okay, exactly the same. So if you put in the values itself, you notice I have sine 30 degrees on this side. I will have 1 times sine 50 on the other side. And you realize that I actually end up with the same exact equation where sine 50 over sine 30, which will give me the same value, 1.53. Okay, now if you use the n equals to sine I over sine R formula, perfectly fine. If you are moving from less dense to more dense. So sine 50 over sine 30 directly. Oh, sure, but this method is much shorter. Sure, I just need to do one step, I get the answer already. But if you try to do the same step for this one, if you use sine I over sine R, what happens is that you end up with 30 degrees over 50. If you press this in your calculator, you end up with 0.653, which is wrong. So therefore, if you hard memorize sine I, sine R, you are setting yourself up for failure. Okay? Remember, whenever we use this formula itself, we must always use big angle over small angle. And if you ever ask, Joe, I'm not sure which one is the bigger angle, which one is the smaller angle, just remember, the one on top should always be in the optically less dense medium, typically is air. So in this case, you have sine 50 degrees over sine 30 degrees. You will also get back 153. Just that, you have to be careful of this part over here. Okay? Now, next part, if you notice a medium with larger refractive index itself is usually optically denser, as I mentioned before, right? So what happens if you notice this explanation here? Basically is the same as the standard explanation that I told you itself, just that you need to elaborate a little bit further. So like I said before, okay, let me see if I can just write it here. So when the light ray, okay, so you can actually just write it here, is that diamond is optically denser than water and air. Water and plastic. Okay, so when the light ray travels from optically less dense air to optically denser diamond, the light ray will slow down more and bend more towards the normal than to water or plastic. So basically you just add on the extra parts to kind of make it into a comparison question itself rather than it being a direct comparison. So you just check if you have any space or any kind of space maybe here, and you just want to just briefly mention this itself. Okay, so or you can just add on to this explanation and you just extend it. Okay, maybe you can just use an empty space to jot it down or make your own set of notes. That's the best actually. So you can actually compare the difference between all of this itself, diamond itself, and whatnot. Okay.